Just one more minute for a couple of folks at the back to get settled and we'll get underway. Both? Yeah. Okay, let's get started. Can you hear me okay at the back? Yep, okay, fantastic. Okay, so thanks for coming to this session. This session's all about troubleshooting Couchbase issues. So we're going to take a look at why nodes fail, why operations fail, and some of the tools that we use to debug these problems. My name's David Haikney. I manage the technical support team for Couchbase in Europe. Been with Couchbase a couple of years. As you might be able to tell from the accent, I'm from the UK. So I'm very, very happy to be across in California, but I must admit I do have a hard time referring to this as a football stadium. It's something quite different. Okay, so what we're going to cover in this session is first we're going to look at the Couchbase server side itself, nodes and why nodes fail. Then we're going to look at the operations, and then if there's time, I know we're a bit tight on time today, we're going to look at some of the tools that we use in the support team that you may not be familiar with. All of the content I'm going to present here is based on hard-won experience, so real customer cases seen in the field, and often learnt the hard way. So let's start with node failures, why nodes go down, what the consequences are, how you can avoid these situations. First thing to point out about a node failure is the consequences aren't really that dramatic. With the replica architecture that Couchbase has, if a node goes down, your replicas will be promoted to active documents, your data set will remain available, and your application should broadly be unaffected. So the first thing we do one of the first things we do in Couchbase support when we're dealing with an issue of a node failure is just offer that reassurance, is to say, hey, look, okay, that one particular node is down, nothing to worry about, your application should be all online, your data's perfectly safe, it's all available. So the first thing to appreciate about a node failure situation is there's often no need for real panic or real drama. So let's take a look at why that happens. So here we have a healthy 4-node cluster, and you'll see I've really gone to town with the PowerPoint animation here. Each of the 4 nodes in the cluster are sending a heartbeat to each other. So every single node is speaking to every other single node, saying, are you okay? Are you okay? I'm okay. Are you okay? I'm okay. Okay, we're all okay. Great, everything's okay. So that's a healthy cluster. So let's take a look at what happens if we take one of those nodes out. So I'm gonna take node 4 down. Again, get ready for the animation. Wow. And so you'll notice a couple of things, that all of the other nodes that we're trying to talk to node 4, their heartbeats are going to be failing. And crucially, all of the nodes will notice that node 4 they're no longer receiving heartbeats from node 4 itself. And this is the reason that this is the thing that triggers the node to be detected as down. Each of the nodes the remaining nodes in the cluster are going to put their hands up and say, hey, I've not heard from node 4 for a while. Have you heard from him? No, I've not heard from him either. And when they all agree that node 4 is not responding, it's at that point they'll decide the node down. If you've got auto failover configured on your cluster, and the auto failover timeout expires, and that defaults to 120 seconds in the current version of the server, then the node will be automatically failed over, and your replicas will be invoked to the cluster. So the real question when we're looking at node failover scenarios is, hey, why did node 4, or why did the node stop sending heartbeats to the other nodes in the cluster? That's what we're really trying to understand when we investigate these things. And there are 4 scenarios why this can happen. So let's take a look at those 4 scenarios. So can't really see that too well, but this is a representation of my alarm clock at 4:15 in the morning a couple of years ago when took a support call. There was a customer in a state of concern because one of their nodes had failed and they were concerned about their business critical application. So very quickly joined a web conference with them, had a conversation, ran some basic diagnostics. And one of the diagnostics we ran is the uptime on the server to see how long the server has been in operation. And lo and behold, the server's uptime completely matched the time at which they discovered that the Couchbase node had gone down. at which point there was a dawning realization on the customer, and they said, it looks like we've scheduled, or we've performed some unscheduled maintenance on this particular server. So the point here is the first scenario, a very, very straightforward, very obvious one. Nodes go down because the server itself has gone down. Often, if you're administering a Couchbase cluster, you may not be responsible for the hardware or the virtual machines underneath. Particularly, we see this a lot with larger organizations. So the first thing to look at is whether, and by the way, throughout this talk, when I say server, server and VM roughly mean the same thing. So the first thing that we're going to look at is the server itself up? Is the virtual machine up? What's the uptime? Crucially, it's not so important if the machine is up now. Was the machine up at the time that you first noticed the Couchbase server was down? So this is running the simple, if I bring up a console. Here we go. So you'll be able to run a simple uptime on your command. You can see that this laptop's been up 16 days. We also have Couchbase itself has its own uptime, so it's aware of how long the process has been in operation. So if you're familiar with the cb stats command, you can run cb stats. If you look at the uptime and the output, you'll see that Couchbase running on this server has been up for 63,000 seconds. Which amounts to 17 hours. So these are the very first simple diagnostics that we do when debugging a node down situation. So scenario 1, the node itself has gone down. Scenario 2, again, very common, is the server may be up, but it's no longer accessible from the network. So again, remember these heartbeats. Each node is trying to heartbeat each other node. If that node loses network connectivity, clearly the heartbeats are going to be lost as well, and so the node is subsequently going to go down. Networks, we have customers on very large and very complicated networks. The clients and the servers are on different subnets. There are often firewalls and load balancers and things like that in between. So oftentimes the connectivity can be lost due to the vagaries of the network. You may see, there are popular reports of people refer to the chaos monkey, or one of my colleagues refers to it as the chaos shark that swims around your data center, causing various disruption with your network, etc. I'm representing that here with my clip art dragon. So the other thing we do, very simple network diagnostics. Can you ping the machine? Can you SSH the machine? Is there anything in your server logs that's in the server's logs themselves? Like on Linux, this would be var log messages that relate to a general network error. Okay? So scenario 3 is the machine. Let's assume the machine is up and operational and that it's accessible on the network. What about the Couchbase service itself? So all of the Couchbase processes, are they all running? So again, on Linux, we'd run the ps command. PS with the Couchbase user should give you a list of all the Couchbase services are running. We're looking for the Beam process, which is our Erlang cluster manager. We're looking for the memcached process, which is handling all of our key value operations, and a few other processes besides. So it's very easy. If you take a Couchbase install on a healthy server that you know is operational, run PS on that server. You can run, and then you can compare that with the node that's gone down, just to make sure that all the Couchbase processes are running. Question there? Yeah, so yes, so the question there was what happens if the server reboots and assuming the Couchbase service restarts, will that automatically join to the cluster? And the answer to that is yes, unless it's been down so long that automatic failover has kicked it out of the cluster. Assuming it's gone down and come back up before the automatic failover timeout, or no one has manually failed over the node, then yes, it will just rejoin the cluster and behave as normal. So as I mentioned here, this is actually a less common scenario because at the top of all the Couchbase processes, we have a babysitter process whose only job in life is to watch all of its child process, make sure they're running, and if it notices that one of the child processes has gone down, it's going to restart it itself. So typically, you will see all of the Couchbase services running. One thing to watch out for is If the memory pressure on your server is too high, Linux has got this safety mechanism called the out-of-memory killer, where if it thinks you're about to exhaust all of the memory, it's going to look for the largest consumer of memory on that particular server and just take out the process. It's quite brutal and quite ruthless. And because the nature of our product, we tend to be that when it's looking for someone to take down, we always tend to be the biggest game in town. So what's going to happen is if your memory pressure grows too high, you run out of swap space, etc., the Linux out-of-memory killer might strike and take out the memcached process. Now, what can happen occasionally is the out-of-memory killer will strike. It will take down memcached. We do have the babysitter, which will detect that memcached has gone down. It's going to restart memcached. Memcached is going to warm up the data again, so the node at this point will still be part of the cluster. But if memcached takes you within the danger zone again, where you can get this situation where you're oscillating, that memcached comes up, out-of-memory killer takes you down, the babysitter restarts it, and you're in this cycle. So one thing to check for in this scenario is you can run a cbstats command and check if the server is warming up. And as long as the warming up is continually making progress, that's absolutely fine. If you ever detect that actually warm-up has started from the beginning, that can be a telltale sign that you're in this scenario. You can check, again, in the system logs, varlog messages or dmessage will give you a line like I've got in black across the screen there that says the out-of-memory killer has been invoked. Question?
The exact same thing also happens when we ran into the 2.2 bug, where the access log becomes full and starts to go down.
You're absolutely right. So the statement there was pointing out one of the bugs that we had. Thanks. In 2.2, so there was a scenario where when the babysitter kicked in, one of our log files, the access log, actually there was a bug that prevented the service warming up, and you got into this exact situation. I will point out that's long since been fixed. That was a 2.2. Okay. So there's the first three scenarios are the server is down, the server's not available on the network, or the service isn't running. Let's look at the fourth and final one. And this is where you need to use a little bit more of your detective investigative capabilities, is that everything's up, everything's running just fine, everything's fine, but for some reason these heartbeats are still going missing. And this can be because the Couchbase service itself is too slow to respond, that the heartbeats aren't being sent out with sufficient frequency in a timely fashion. So I've listed the 4 most common reasons that this can occur. So for Linux deployments, there is a kernel feature called Transparent Huge Pages, or THP, that interacts horribly with not only Couchbase, but many other database systems. So we make a very strong recommendation to ensure that THP is disabled on your server. It's a very common cause of nodes automatically failing over, and we see it very, very frequently in the logs that we receive from customers in support. So we make this very strong blanket recommendation to disable THP. The second reason that the Couchbase can be too slow to respond is we end up trying to do too much on a Couchbase cluster, that the amount of workload that you've placed on that cluster is too great for the physical resource that you have. And I'll talk a little bit about sizing in more details in the next slide. Also, I mentioned memory pressure there. Swap, so if a lot of your memory is actually paged out to disk using a lot of swap space, again, that's your server's going to underperform, and in the extreme case, that can cause these heartbeats to go missing and a node to go down. Quick note about virtual machines. In a virtualized environment, there are a couple of things that the hypervisor can do that can also cause some pauses within the VM. So virtual machine migration, that's when you're migrating a virtual machine from one physical server to another. There's a period during, so for example, VMware's vMotion. There's a period of that process where the hypervisor has to cease operation temporarily on the virtual machine while it's transferring the last few bits of data. So we guard against virtual machine migration. Question at the back? It sounds like you work for Couchbase support, sir. So the statement there was, why would you bother using vMotion? Because we've got, Couchbase comes with all of the rebalance, the dynamic scale capabilities. That's absolutely correct. Yeah, so it's covered quite extensively in our online docs, so docs.couchbase.com. And I think there's a blog about specifically to do with virtual machine recommendations. One of the great powers of virtual machines is that you can overcommit. Your physical machine might have 8 CPU cores, and then you create 3 virtual machines, each with 4 cores each. Now, clearly, you've only got 8 real cores, but you've somehow fashioned 12 cores into life. In a sense, we'd say you're cheating. And if you take that too far to the extreme, again, it can cause the virtual machines themselves to suffer pauses while the hypervisor shuffles everything around. So very strong recommendation. Don't be too greedy. Don't overcommit your VM resources. If you find this strikes a lot, so actually in 2.2, our auto failover timeout used to be 30 seconds. We actually found that the nature of the data center, this was actually a little too sensitive. So in recent releases, we've actually increased that to 2 minutes. So one thing to do if you find out, you can, if your cluster is suitably sized, if your hardware is very reliable, it is possible to tune that back down from 2 minutes. We've gone for a rather conservative default. But another recommendation we often make is actually if you've perhaps been a little too aggressive with the auto failover timeout. Quick note on sizing. So one thing we see very commonly is that over time, data sets grow, additional use cases are added. So whatever you set out originally to do on your cluster has expanded over time. There are a few actions or activities on the Couchbase server that are going to occupy a bit of CPU resource. So you've got all of the heartbeating going on. You've got all of the statistics are being collected. So for every bucket, for every design doc that you're using for index and querying, for every XDCR stream, that's going to occupy a little bit more CPU resource. And so what we make a general rule of thumb for is 1 core per bucket, 1 core per design document. And these numbers here are taken from a real customer scenario where they had quite significantly kind of overloaded the cluster, and as a result, they were seeing very, very frequent failovers. A colleague of mine, Perry Krug, is going to give an excellent talk on sizing recommendations on this track at 5:15 today. So if you're interested in hearing more about sizing your Couchbase cluster appropriately, feel free. He does an excellent job on that. Okay, and that really is it. That covers the most common reasons why we see nodes go down. It's either it's exactly those 4 scenarios. The server's gone down, it's not available on the network, the service has somehow been stopped, or the service is too slow to respond. That basically covers it. So in your own environment, if you just follow those simple sort of 4 steps and logically go through them, chances are, I would say 9 times out of 10, you're going to understand exactly why your node has gone down. Any quick questions on that before we move on to operations? Yes? Yes. Okay, so the question is, you have auto failover configured. Your server goes down for 2 minutes and 30 seconds, and then it comes back up. So assuming it has good connectivity, the other, let's say the 4-node cluster, the other 3 nodes after 2 minutes are up. It's going to say, okay, node 4 is gone. We're going to take responsibility for its data. The replica copies on that data will then be promoted to active, so you have full access to your entire data set. And when the 4th node comes back up again, it will be informed, it will be told that it's out of the cluster and it's no longer participating. And then it requires intervention to then add it back to the cluster and use the standard rebalance operation. And we have, as of the Couchbase version 3, we have this delta recovery, we call it. So rather than rebalancing all of the data set across again, you just need to send across the changes since it was last participated in the cluster. That makes sense? Okay. So let's move on then to the application side. Oh, sorry, was that one question in the back? I'm sorry, could you say that louder? Or do you want to come forward and ask? I couldn't quite catch that, sorry. Yeah, so I think in the previous, for those that caught the previous session with Anil put it very nicely, is that whilst that rebalance is ongoing, your data is all available, there's no downtime, your application should be running. It's just the process of having that node rejoin the cluster. And that rebalance operation is going to restore the cluster to, I think Anil put it nicely, described it as optimal health. So there's really, we deliberately don't deprioritize rebalance so that the main event of the application traffic, the key value operations, and we let the rebalance run as a background process. So we would just typically recommend that when you're ready, when you've understood why the node has gone down, when you're confident that that node is fit and healthy again, to then just rebalance it into the cluster and let that rebalance take its course. That make sense? Okay, thanks. Okay, so let's move on to operations. So again, probably the second most common question we get asked in Couchbase support is, why did something go wrong in my application? Why did my operation fail? So in order to understand that, let's just remind ourselves of what the path, the flight of an operation looks like. So this is a very typical setup regardless of your language. If you're a .NET developer, Java developer, Node.js, whatever, you're going to have your application code written in that language of your choice. You're typically going to interface with a Couchbase SDK that's going to provide that API, the interface to all of these operations. And so for a get operation, say I want to receive the value corresponding to this key. The SDK's job is to hash that key into one of our, every Couchbase bucket we have, we shard it into 1024 vbuckets that are then distributed across the server. And so what the SDK is responsible for is taking that key. It will then hash it to one of those 1024 vbuckets. It then looks up, when the Couchbase SDK first connects to the cluster, it gets the topology that says these servers house these following vbuckets. So what we refer to as the vbucket map. So it takes the key, it determines which vbucket that corresponds to, it looks it up in the vbucket map and it says, okay, this key lives on this server. It will then go and connect to that server, perform the operation, and wait for the response. Very, very simple, very straightforward way the operation goes. But we're not here to talk about how operations work. We're here to talk about why operations don't work. So let's have a look at some of the things that can go wrong. Firstly, is the operation couldn't be dispatched at all, that there was a problem sending the operation out. And this can happen for a few reasons, which I've listed here. So if the Couchbase server is configured to have a maximum number of connections on its data port, the port 11210 is configured to have a maximum of 9,000. Now, if you're in a very large, very scaled out environment where you have a significant number of clients, particularly we see this occasionally with PHP, what you can do is you can exhaust that number of client connections. And so if you try and create a new one, the connection to the cluster is going to fail. The client object is going to fail to initialize, and any attempts to perform an operation on that are going to fail. Another common reason we see is with Java. So many deployments have Java, which includes some element of garbage collection. And if you have a very memory-intensive Java application or a very long-running one, you may encounter stop the world garbage collection that pauses for a significant amount of time. And this can mean that an operation times out before it's even had a chance to leave the server. Because just as your application has sent it, Java said, hang on a minute, I need to do some tidy up. And then the operation doesn't fail. So something we often recommend is to make sure your garbage collection is tuned appropriately. And something that when we're investigating these issues, we review the garbage collection logs. Another reason is that the node itself is unavailable. So the scenarios that we just discussed when the node is down, obviously if the client is going to try an operation to a node that's unavailable, that operation is not going to succeed. Secondly, and the return of the clip art dragon is obviously this operation is going to go out across the network. Again, across possibly a different subnet, possibly through a firewall, with a network with fluctuating load on it, occasionally fluctuating quality. So it's very, very important to understand what the quality of the network is and whether or not did the operation leave the the client okay? Did it arrive on the server okay? When did the server respond? Did that response make it all the way back to the client? So we see various different issues where you might have the host file configured differently on one particular client, or a DNS entry changes. All of these kind of scenarios can help explain why an operation failed to complete.
Typically, when we get a timeout exception.
Yes.
So when I get a timeout exception, how do I distinguish between whether it was network related where it couldn't reach a node, or was it because I was spreading the local network itself?
Yes. So the question there for those at the back was, if you see an operation timeout, how do you know if there was some condition on the network that caused that to fail, or whether or not there was a problem with the server or itself? And the answer is that we're back to the slight sort of detective scenario again, where you have to perform the good science and say. So one thing we commonly do is look for a pattern. If operations are failing, we'll say, are they all failing from the same client? Is there one particular client that's affected? And that tends to suggest that's where the problem is. Are operations failing to all of the Couchbase server nodes, or is it one server node in particular? And so with those pieces of information, you start building a picture of, okay, it looks like this one client is having issues, or this one server node is having issues. If the situation is more murky than that, if it's a multitude of clients, if it's a multitude of servers, then maybe that suggests it's something with the network itself. You may want to review your firewall or your garbage collection in general. So there are a couple of steps you can help to do to diagnose it. So one thing we do is recommend you have a very simple, you can write about 5 lines of Python that will retrieve a key for you and print that out. And then you could run that on the Couchbase node itself to say, if I run this command on the Couchbase node, do I get a good response? If I run it on this client, so there's no kind of hard and fast light that's going to tell you that answer, but there are a few sensible steps that you can take to really isolate the problem and say, is this a server thing? Is it a client thing? Or is it a network thing? And it's following those steps. So we also have, so when what we say, if all else fails, we crack out TCP dump and Wireshark. So these are network inspection tools that you may be familiar with. And what they're going to do are capture the packets that are flying around on the network. So a quick view of this. I don't know how clear this is at the back. But TCP dump is a tool capable of capturing the packets on the network. Wireshark provides a nice UI to visualize those. Wireshark, in the last 12 months, we've extended it with Couchbase support. So if you load a Couchbase packet capture into Wireshark, it'll print you out what you see here. So you'll see it knows it's the Couchbase protocol. It knows it's, in this case, a set operation. And down here, you'll see things like the key that was being used and the document that was being sent. So what we can do is you can capture the traffic that's emerging from the client. You can capture the traffic that's arriving on the server. And again, build up a bit of a picture of exactly what's going on. Now, I would say that just capturing all the traffic on your network is going to be tremendously noisy, so filter it appropriately. We tend to limit it to one particular client, one particular server, and you tend to only need the Couchbase data port. That's port 11210 on the Couchbase server. Another question?
Coming back to the client, Couchbase client is aware of the scenario where its local the NetEQ is getting flooded.
Yes.
So instead of timing out there itself, it can probably set some a more descriptive error message at the top.
Yes.
Versus just the same old timeout.
Yes, and I believe the recent version of the Java SDK does exactly that. Yeah. So again, for those at the back, the question was, so some of the SDKs internally have their own queues for queuing up the operations ready to be dispatched to the server. What happens if it fails to depart that queue in time? Surely the SDK is sufficiently aware to say, actually, this is a different type of error message to the general network one. And you're absolutely right. That's in particularly for Java, the latest SDK does that. So one final reason that operations can fail. There's actually a slight subtlety here, is that some operations, they actually complete successfully, but you might not get the success status back that you expected. So there are a few reasons for this. I've got a fun example of an operation failing because the key didn't exist. The customer originally, the Couchbase admin originally insisted it did exist, and we said, hey, well, we see you doing deletions, and they said, okay, let me go back and check with the application team, and lo and behold, yes, there were some deletions occurring. Another very common one here is when your data set is larger than your memory quota, the DGM scenario that we talk about, what can happen is, particularly if you're doing a big import into Couchbase, a bulk load, you can get to the point where you hit the limit of the quota, and then Couchbase needs to manage the cache. And so what we do is we've got a high watermark for this exact reason. And so when we hit the high watermark, we then start managing the cache and say, okay, we need to take some of those items in memory and make sure the push to disk and free up some space to be able to incorporate some new ones. Whilst that is happening, Couchbase server can send some backoffs to the client and say, hang about, I'm busy just now. We call them temporary out of memory messages. And so it may be that you submit a set operation to the Couchbase server, and it's quite perfectly legitimate for Couchbase server to respond to that and say, no, that operation's not going to succeed right now because I'm temporarily out of memory. And the recommended behavior for that is to basically just simply retry the operation with maybe 2 or 3 times with a backoff or an exponential backoff. Okay, that's it for, and again, pretty straightforward, pretty logical, the reasons why an operation can fail. It's check for any pattern if it's particular clients are affected, particular Couchbase server nodes that are affected. Check the health of your network. Run some, you can, with a simple sort of 5 lines of Python, you can run the same operation in different scenarios to try and pinpoint and isolate where the problem is. And then you've got tools like TCP dump and Wireshark when you really need to get into the guts of it and go for a deeper understanding. Question?
So internally, Couchbase has thread pools, and I would imagine they have work queues that feed those. Is it possible for an operation to get rejected because it runs out of queue space, or is the queue like sort of unlimited?
It's not unlimited, but you're going to hit the operating system's own, the network driver's own internal queues before you're going to hit Couchbase's queues. So it might be theoretical, but never seen it. So there are no queues to worry about on the Couchbase side there. Okay, so the final section, just want to give you a quick whistle-stop tour of a couple of tools that we use. So the scenario I'm going to go through here, and you'll excuse the nursery rhyme. I have a couple of young children, so I tend to spend most of my waking day with these nursery rhymes flying around my head. So this one represents when we've got XDCR going between a source cluster and a destination cluster. And the source cluster has, let's say, 5 million documents in, and the destination has 5 million minus 1. And so we need to try and figure out, hey, what the hell's gone wrong? Was the document too big? Was there something wrong with the network? And in order to try and get to that point in the investigation, the first thing we wanted to do was to understand which of the documents had gone missing. And so what we could have done is we could have dumped the entire data set, taken an entire backup, poured through that backup, but that would be, particularly for a large data set, that would be quite a laborious and time-consuming operation. So I just wanted to show you a couple of tools that we used in order to help debug this. How legible is that? Is that readable enough at the back? Can you see the text? Or there was a shake of the head. Let me go even bigger. Right. Okay. So the first thing we wanted to do is, I mentioned that Couchbase bucket is split into 1,024 V buckets. So what we wanted to do is try and isolate, so the investigation here is to try and find which of those documents has gone missing. So what we did was we took a look at the number of documents within each of those individual V buckets. And that's done by the CB stats command again. So typically, when you run CB stats, you run it with all, and you get how many sets, how many deletes, how many gets you've done. You can also give it a vBucket details parameter when it's going to look at all of the vBuckets on that particular node and print out, amongst other things, the relevant thing that we're looking for here is the number of items. So how many items are in that individual vBucket? And so with a very small amount of grepping and sorting, you can build for one cluster how many items are in each vBucket on that cluster. Now you do this on the source and the destination. You've got two lists, a list of how many items are in each vBucket on the source and how many items are in each vBucket on the target. You then diff those two things and you'll come up with something like this, where, okay, on the source cluster, my vBucket 12 has got 78110. On my destination cluster, I've got 78109. So very quickly, I've taken that entire 5 million data set and I've narrowed it down to 1,024th essentially by pinpointing which vBucket is affected. Now, I still have the question of, okay, I know the vBucket, but I'm really looking for the document that's gone missing here. So to introduce another tool that you may not know, we've got so in your Couchbase data directory, you will have a directory for all of the buckets on your cluster. So here you can see I've got a Connect 2015 bucket. If we go into that directory, you'll see I've got a number of files, and each of these files corresponds to a vBucket that's on this particular node. Yes? This is Couchbase 302 I'm running on this cluster. So we have so in your data directory, we have a couch store file here. And so when we talk about things being pushed to disk, when you see a disk write queue, this is where these suckers end up in one of these couch store files. We have a tool called Couch. Oops. Let's see. Here we go. CouchDB dump. So we saw from the previous diff that it was vBucket 12 that had the missing item. So CouchDB dump is going to take one of these couch store files. In this instance, it's vBucket 12, so it's 12.couch.1. And if you run, you can do a bunch of things. You can either dump the entire content of that, so that's the keys and the values and all the metadata. In this, I've passed the no body flag, so I just want the keys and the metadata. And you get output that looks a little like this. I use, if you're not familiar with this, there's a fantastic JSON command line parsing tool, JQ, that can prettify it, so you get a much nicer output there. And then, so what we do with that is we can just select the IDs. So with that one command there, CouchDB dump, that's able to very quickly dump out all of the keys in one particular vBucket. And again, we can play the same game that we played with the vBucket IDs. We can do this for vBucket 12 on the source cluster, vBucket 12 on the destination cluster. And you'll see something that looks approximately like this. In my source keys, I have a document here. In the destination keys, I have something missing. So CouchDB dump with a simple bit of grep and sort, compare the source and the destination, and all of a sudden I found which of my 1 in 5 million documents are different. Then then we would go ahead and look at the document, what was special about it. Was it particularly large? Did it have any special metadata associated with it, etc.? And that's how we use to debug it. Okay. Whew. So last slide. That's the long and short of it. So you now all know the most common reasons for nodes failing over, how to identify and detect them, and the reasons that operations tend to fail. And really the advice is that the most common explanation is obviously the right one. And by simply following quite a logical set of steps on the investigation, you can really pinpoint and isolate and understand why that is. I've not mentioned rebalance here, but you'll see it in Couchbase. There's a log tab. Oftentimes, for our sins, the logs come out with a nice healthy dollop of Erlang internals, which aren't terribly meaningful unless you're an Erlang enthusiast, which I know many of you are. But one thing you can do with those is go to, I say here, we're an open kitchen. All of our bugs are available to look at online, issues.couchbase.com. And so what you can do is paste little extracts from that into the search bar and say, hey, is this an issue that's cropped up before? And you'll quickly get a sense of, is this something that's only applicable to this version? Is there a workaround it? And things like that. And when all else fails, you do have the support team on hand. So we offer 24/7, 365 support. We've got teams, myself in Europe, we've got America, we've got India, each of which are co-located with a development to give you a real expert insight into what's going on. As I say at the bottom, but hopefully you'll never need us. Okay? With that, I'm done. Thank you. So one quick final thing before you go, I wanted to put a shout out for if you've downloaded the app. Please make sure you fill in the feedback and enter yourself for the prize draw, because there's something to be won. There's a prize to be won, and I hear the prize is fantastic. Okay.